Here's your integrated 312.1.1 lecture. So it's analyzing trig equations. So I'm just going to do 12-1 and 12-2 and 12, yeah, 12-1, 12-2. So it says, how can you tell which values of x make an algebraic equation in one variable true? For each of the following equations, work with your team to decide if the equation is always true, sometimes true, or never true. If it is always true, justify how you know. If it is sometimes true, give the exact value of x that make it true. And if it's never true, explain why it's never true. So we have these four, A, B, C, and D. So basically, let's do a little algebra and try to solve. I can see just by looking at this one that this one's always going to be true because this is 5x minus 35 equals 5x minus 35. So that means that no matter what value of x I plug in there, it's always going to make it true. I could plug ones in both sides or zeros in both sides, and it's always, the left-hand side is always going to equal the right-hand side. So this one, so I would just write always. It's always true. I'll write always true. I can plug anything in there for x, and it'll always be true. But what if I look at this one? This one, it started out as 2x squared minus 50. Then I divided both sides by 2, and I got x squared is 25. So I know x, this one's only true if x is 5 or negative 5. So I'm just going to write sometimes true. It's only true when I put a 5 or a negative 5 in there. Okay, this one, we'll do some algebra on here. So this one, let's see. I'm going to distribute this negative sign. So 4x minus 3x is x. I got x minus 2 equals x minus 7. I'm pretty sure this is going to be never true because if I subtract x on both sides, I get negative 2 equals negative 7. That's never true. There's no value of x I can plug in there that would be the same if I subtract 2 from it, the left-hand side, and then if I subtract 7 from it, it's not going to end up the same. Okay, so that's never true. And then this one, let's see how your algebra is doing. This one I'm going to do fraction busting on it. I'm going to multiply both sides by 12. So 12 over 1. So the 12 and the 3 cancel out, and that leaves me with 4 times 2, which is 8. And here, when I multiply by 12 over 1, the 12 and the 4 cancel out, and I get 9 times 2x plus 5. And then I'm going to try to solve that. So 9, 8 times 9. So this one's sometimes true. It's true when x equals negative 11.7-ish. So I'm just going to say sometimes true. I wouldn't have even gone through solving it except for that they told me what value would make. They told me to write down what value would make it true. So why are we doing stuff like this? Well, you're going to be learning some trig identities. And so that was your warm-up, I suppose. So on 12-2, it says, when is it true? Your task. Given the following equations, decide if each equation is always true, sometimes true, or never true, and justify your decision using as many representations as you can. If the equation is always true, explain how you know, then look for ways you can change the equation so that it will never be true. I'm not sure we're going to do all that, but we are going to go through each and look at them. If the equation is sometimes true, determine the exact values of x that make it true. Then decide how you can change the equation so it'll never be true. We're not going to have time in this video to do all that. If the equation is never true, explain how you know. Okay, let's look at the equation. So they have sine of x is a half. So think about that. Is there a time when sine of x equals a half? Is it ever true? Let's see. I got my unit circle here. Is sine of x ever equal to a half? Sine, let's see. Sine of x is equal to a half when x is pi over 6 or 30 degrees. It's actually also true over here. 5 pi over 6 or 150 degrees. So I'm going to say for A, I put a little tiny s there for sometimes true. And then B is cosine x equal to 2? Can cosine x always, or are there values of x where cosine x is 2? Because it looks like I'm wanting to say that's never true, because I know that cosine are on my unit circle, they're these values, these x values. My cosine values are never more than 1. They're always between 1 and -1. So I'm going to say that's never true. Cosine x is never equal to 2. Is sine x equal to cosine of pi over 2 minus x? Well, I think sine x is the same thing as cosine pi over 2 minus x. Because that's 90 degrees minus x. So let's look at a triangle. I think it would make more sense if we looked at a triangle. Let's say this is a 30, 60, 90 triangle. So on a 30, 60, 90 triangle, we know this is 1, and this is 2, and isn't this root 3? Yeah. So if I say that the sine of 30, remember sine is opposite over hypotenuse? Sine of 30 is a half. I can look right at my triangle and see that. But what about the cosine of 90 minus 30? Is that the same thing as sine of 30? Is the sine of cosine 90 minus 30 the same always as sine of 30? Because I think it is. Because what is 90 minus 30? It's this other angle. And even if it weren't a 30, 60, 90 triangle, the other angle, like if, let's say this triangle has 52 degrees, this one is going to be 90 minus 52, whatever this angle is. So this other angle, cosine, is adjacent over hypotenuse. So isn't that also 1/2? Because cosine of 90 minus 30, which is 60, that's adjacent over hypotenuse. So it turns out that this is always true. And even if you look at a sine graph, and I don't want to get that far into it, but if you look at a sine graph and a cosine graph, I guess I'll show you a sine graph and a cosine graph. So here's a sine graph. And then here's a A cosine graph. It's not drawn very well. So a sine graph and a cosine graph, these little points right here like that, they're always 90 degrees apart. So you can check that out, get out a graphing calculator, look at that a little bit more. And you can tell even when you look at these numbers. See how the 30, the cosine is root 3 over 2. And then see how that same root 3 over 2, it's the sine of 60. See how the numbers are kind of the same? So I got a little carried away on that one. But that one is always true. When is sine of, let's get back to letter D. Let's look at letter E. When's tangent of x equal to 0? Or is tangent of x ever equal to 0? Well, tangent of x, tangent is sine over cosine. I don't know if you knew that, but tangent. So sometimes cosine x is 0. Like, let's find a place where cosine x equals, or sorry, sine x. Sometimes sine x is 0. When is sine x ever 0? Let's see. Sine x is 0. Let's just use this one. So tangent of 180 degrees, or pi, would be sine over cosine. So it'd be 0 over -1, which is 0. So tangent is 0. Sometimes tangent is 0. So we're just going to say sometimes. But not always. Tangent is not always equal to 0. 2 times sine x equals root 3. Well, if I divide both sides by 2, then I'd have sine x is root 3 over 2. There, I can see that there's lots of places when sine x is root 3 over 2. Here's one right here. It's not always root 3 over 2. Sometimes it's root 2 over 2, but I'm going to say sometimes. Sometimes this is true. And I guess, you know, the directions said I need to say when that is. Well, I'm going to kind of skip to in for the sake of time, but root, pi over 3 is one occasion where sine x is equal to root 3 over 2. Is sine x ever equal to just regular 3 over 2? Well, I'm going to say never, because sine is never 3 over 2, that's 1.5. And sine is never more than 1. It's always between -1 and 1. So that's never true. And then this one is the same as this one over here. When I was showing you the triangles, sine of pi over 2 minus x is the exact same thing as cosine x, always. And same thing with this one. So these ones are related. They're always true. Now let's go back and look at this one. Is there a time when sine x is equal to pi over 2 minus x? I actually don't know. Let's see. Is there an x? 2 minus x. I think I'm going to let you guys try to figure that one out. It says it's sometimes true, and I'm going to let you guys try to figure that one out, and then we can talk about that in our Google Meet on letter D. You can decide if